So good afternoon all. In yesterday's class we have studied about perpendicular bisector theorem and converse of perpendicular bisector theorem. Today we are going to learn what exactly angle bisector theorem is. So in the case of angle bisector theorem, consider ABC is an angle where B is the vertex of angle, AB and BC are the arms of the angle. I have constructed BD as a bisector of angle ABC. So it means that these two angles are equal. Equal angles are angle ABD is congruent to DBC because ray BD is angle bisector of angle ABC. According to the theorem, any point on the angle bisector, if I consider any point on this angle bisector, let us consider P is a point which is on the angle bisector. If I construct perpendicular from P on the arms of the angle, it means PQ and PR are the perpendiculars drawn from the P which is on the angle bisector on the arms BC and AB. So these distances are equal. PQ is equal to PR. It means that point P is equidistant from arm AB and arm BC. Likewise, I can consider many points on this angle bisector. In each of the case, the point which I considered is exactly equidistant from the arms of the angle. Let us consider another point, that is Q. So if I construct perpendiculars from Q on the arms, you will notice that the distances of this is again exactly equal. So Q is already taken by me, so let me change the name. It will be X, XY and XZ. So the result is length PQ is equal to length PR and length XY is equal to length XZ. Why we are getting these distances? Because we have taken those points on the angle bisector, and according to angle bisector theorem, these points are equidistant from the arms of the angle. Now let us see the exactly reverse of this theorem, that is the converse of angle bisector theorem. In the case of converse of angle bisector theorem, let us consider any angle of any measure. Measure is immaterial, we are considering any measure of the angle, and in the interior of the angle, if I have taken a point P, and if suppose I construct two perpendiculars on the arms, that is PQ and PR, if these perpendiculars are equidistant, then we can say P is a point which is exactly on the angle bisector of this bigger angle, angle ABC. So BP is an angle bisector. It means that P is on the angle bisector because it is equidistant from the arm AB and BC. So likewise, I can consider any point in the interior at any location, but from that location it should be equidistant on the arms. If it is equidistant, then only we are in the position to say this point is on the angle bisector. If for understanding I shift the location of that point, you will notice that after constructing the perpendicular, I will find different distances from the arms. And if suppose it is not equidistant, we can't say that it is on the angle bisector. The result is in front of you. In this kind of situation, this point is not exactly on the angle bisector. This is very small angle and another is the bigger angle compared to the previous angle. So this is not the case of converse of angle bisector theorem. This is the case of converse of angle bisector theorem, where the P is a point which is equidistant, therefore it is on the angle bisector. So this way we have studied two different theorems, angle bisector theorem and converse of angle bisector theorem. Thank you.